Looks like YouTube added notifications for when the channel goes live. Neat. Okay. I've got a nice little list of tasks, which I guess should be a numbered list. Are these tasks for this stream? Yeah, sure. As I said with the note up the top, this plan is based on some of the currently supported functionality, so expect me to be copy-pasting code for a lot of this. And saving this to... And I'll just save that and open preview. There we go. If you make... Visual Studio Code needs native support for task lists, but just putting things in code blocks at least makes the formatting a bit cleaner. Like I said, nice and clean. Step 1. Get a virtual machine started using Cube and outputting to the screen. Let's do this in the terminal first, just to show where we're going. System x86-64. Let's first make sure that we have a kernel. Also, just to avoid leaking things, I will do this one here. Build. Oh, that's right, I actually have official kernels on GitHub and I have for some time. The kernels are a bit out of date now, that's something I do want to work on. But it's just this right here. There we go. So all you have to do is cubemusic's serial stdio and graphic. And I'll kill this in the background. Annoying. Anyway, you do no graphic, kernel, local, then the kernel name, so that it direct boots, and no output. No, nothing. Reset just to make sure that it doesn't make things annoying. You need append console equals tty s0, I believe. There we go. We've got a kernel booting that can't find a rootfs as expected. All we want to do is get Go to do that, but in a relatively nice way. And also can just do no reboot, panic equals referring over to my other code that I normally use. reboot equals K, panic equals -1. Is it called no reboot? No dash reboot. Then it goes do 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 ding. Oops. Then we enable KVM, and all this goes a lot faster, unsurprisingly. So pretty much all we want to do is run this command line. Easy way is exec.command, and then basically just pass this in. It's already got quotes around it, so I don't need to do that again. And finally, no reboot. Run. If error run. No log dot fatal. Go run. Dot slash TinyRange. Oh, no output. cmd.stl equals os.stl. Voila! There you go! Launching a virtual machine from Go. Step 1 complete. But no. That is, in the end, what we're going to end up running effectively, but we're just going to add a few layers of abstraction over it to fix a few things. So, number 1, all the code that we've written so far is theoretically compatible across whatever operating system Qum supports. And with the current closed source code in TinyRange, this works the same on Linux as it does on Windows, as it does on macOS, as it does on Android, as it does on FreeBSD, OpenBSD, NetBSD, Solaris. Essentially, if it runs Go and Qum, it'll run this kind of TinyRange thing, which is where we want things to be. Which means that we're not going to be able to just run this same command line exactly the same for each system, because for every operating system that we're running on, the command line that we're actually going to end up running is going to be slightly different. It's also going to be optimizations that we want to do to this. The short version is, instead of just putting this exec command thing in directly, we are instead going to have a Starlark. We're instead going to have a Starlark script that handles this for us. So we'll make a hypervisor directory, and under that we'll make a Qum directory, and under that we'll make a hv qum.star and qum.star. Cool. And we will make this take a context object and then return an executable. And then we're essentially just going to do this. Oh, didn't want to do that. We're essentially just going to run this exact same code in Starlark instead of in Go. That means people can modify it. That also means we can gradually go through and fix all the reasons why this is a terrible approach. Why this command itself will actually need to be changed and modified quite substantially. I'll go into exactly why that is later, but in short, this is for an x86-64 virtual machine that is booting just a kernel, and doesn't do anything else. We don't have any user land for the kernel, which is why it's kernel panicking as soon as it finishes booting, because it can't find it in process. So we'll need to make a lot of changes to it. That's why we're starting off with abstractions. So we'll have a virtual machine, and we'll have a func VM star virtual machine run, which will have an error. And step one, we're actually not going to use this code anymore. We're going to use the Starlark code instead. So we have a package main virtual machine, VM equals new virtual. Having constructor functions like this in Go is something I tend to prefer to do, just because I've had too many cases where I've just randomly been creating structures ad hoc all over the place, and everybody gets a slightly different implementation, and it can be very bug prone. One of the annoyances I have with Go is not error handling. Error handling I really like in Go, but the annoyance is lack of null safety. So null pointers, especially null pointers on maps. Why aren't maps properly initialized from the start? I know it's going to be some heap allocation thing, but so let's just return a virtual machine. Right, and then VM.run. F error VM.run, return nil. So I should probably be keeping an eye on the YouTube dashboard things as well. Since for whatever reason I did decide to make this public. Log.fatal error. Log is the old way of doing logging in Go. I much prefer the new slog system, but slog doesn't have slog.fatal for some reason. And just being able to do a basic fatal log message primarily from the main function is really useful. I could just do some wrapper. Actually, no, let's do this right. Func. TinyRange main. Error. Okay, so I will just save that because that's annoying me. But how about func main error equals if error range main to nil, then exit one slog.info slog.error. A lot of mistakes as I'm writing. Okay. Now that's nice and clean. So what we're going to do from here is we're going to run a virtual machine factory function, which is what I will call this thing. Takes a context, returns an executable. Context will contain all of the different parameters to say like, oh, does this host support acceleration? And what kind of functionality does the guest kernel we're booting up support? Like, how are we going to need to configure things so it can get to the goal that we want to get it to? Okay, so we will do virtual machine run. So I'm going to use a factory pattern for this, but the factory's actual method is essentially calling into a piece of Starlark. So all this has is it has a callable, which is a starlark, which is a starlark.callable function virtual factory file name string returns a virtual machine factory and an error. So this function will evaluate the actual top level Starlark file, and we'll need to give it a series of global variables, which we'll just create. Factory is a virtual machine factory, return factory nil error, factory.load, file name, nil. Just have go on tidy running in the background. Func factories virtual machine factory load file name string just returns an error. Now we need a thread first, which is going to be a Starlark thread. Setting the name is best. Globals is starlark.string dictionary, and we'll have a type factory. I'm just prefixing these things for convenience. I should theoretically be separating this out into a bunch of modules, but I like, at least initially, having the entire source code just in one file, because I can always go and split things up later, but for now it means that I can go through and do design changes a bit easier. So command is a string, and so command is a string, and the argument is an array of strings. If we look at this, the command is the first string, and then the arguments is the remaining list. Let's just be a bit more explicit about this. Both because this code is a bit more readable, and also to make dealing with the string argument parsing in Starlark a little cleaner. So we have a vmin factory executable, and because this is a value that goes through Starlark, it always needs to be a Starlark value. And for Starlark values, there's a little snippet of code that I always like to use, which I will pull from PKG2. That is essentially just a really simple implementation of Starlark value. You need to implement at least these methods to make it work. I will remove that prefix from all of them, just because the public user API doesn't need to know that internal prefix. And this now means that this can be returned from a function. And I will do declared error is equal to starlark.file exec file, which is deprecated now, which means we need to set options. Yes, I do want sets. I have nothing against while statements, although I don't think they're strictly needed here. Top level control is useful. It just means you can put if statements and other things at the top level, and these other things I don't really care about. And then the remaining arguments to this are the thread, which we already created, the file name, pass it nil, and it will load it from the file system itself, and globals. to nil, then return error. Otherwise, we want to find the main function and declared main func. Okay is declared main. If not okay, return could not find main function in machine factory. If callable okay equals main dot starlock callable okay expected as expected callable got as so this is why they expect you to implement that minimum set of functions. You have to implement string because that's what happens if you cast that value to a string. It also means, because it implements the underlying format string printer in Go, it means that if you print it out in debugging output, it'll print that string value as well, which is handy. It's like what happens if you do print from starlock. Type is the type name if you do something like type val. Hash is if you're putting it into a hash map, which I'm not going to allow this to be put into a hash map, so I just returned an error saying it's not hashable. Truth is this a truthy value or a falsy value? All of these values are truthy. If it was falsy, then that would just influence if you could do if val. And finally, freeze. Starlock freezes all values as soon as the scope that they're declared in is exited out of, more or less. The reason Starlock does that is so that it can be thread safe. But I'm expecting to handle my own thread safety for this, so I just make freeze and OOP. It means that I do my own synchronization using mutexes rather than like preventing any changes or modifications after a value has been created. But the Starlock values themselves do freeze by default. So I'll check to see that this is callable, and then factory.callable equals callable. Then I will just return nil. Alright, so I now have a factory, so I need to be able to create the virtual machine from the factory. Let's just write this up here. That context value that's passed in is also going to be a virtual machine. So that means it needs all these values as well. So let's make virtual machine a starlock value and all of these as well. Alright, and then to actually run. So this isn't handling running a virtual machine yet. This is just handling creating. Func factory star factory is virtual machine factory create. Which just returns a virtual machine and an error. And virtual machines internally have factory con virtual machine factory, because when they actually run, they do essentially ret error equals starlock.call. Thread. I'll just call this thread virtual machine. You can get access to the thread names later, they're kind of handy. So we'll make a starlock tuple, and we'll pass the VM as one of the properties, and then my keys fell off the keyboard again. this is just a regular starlark tuple, that one's an array of starlark tuples. Also, I have zoomed in this instance of Visual Studio Code a little bit, just to make it easier to see. I know that for me at least, sometimes I'm watching YouTube videos on a phone, and not being able to read anything is rather annoying. Okay, if exec okay ret dot executable okay. If it's an executable, then we're just going to do env.run exec. Also going to turn format to error f. Expected s got expected principal got something else instead. Got whatever ret dot type is. And now we just have virtual machine run executable exec. This just returns an error. Right. And then now cmd is exec dot exec dot command exec dot args. See, easy. cmd dot stood out equals os dot stood out cmd dot stood out. Then return. I'm going to refactor all this code later, but this is just getting it runnable. This will just return a virtual machine with the factory set to factory and no. So step 1, factory error equals load virtual machine factory hv vmu star. Then vm factory.create error, and then finally vm.run. Cool. And now we should be able to run it, except that we've got the executable undefined. It will helpfully tell us exactly where that happened, and we can also see that our little error fatal thing is working. Cool. All that error is because is we didn't declare the globals. Globals executable. Globals built in executable. And okay. Command string arguments string. Arguments is actually an array, or is actually a starlark.iterable. That means you can pass a list. That means you can pass any value that implements starlark.iterable into it. Now we just need to call if error is starlark.unpackargs. Name Command. Command. You may be able to tell that I've been writing code pretty much exactly like this for the last ages. And so I've become quite adept at it. Hopefully. I know there's still plenty of improvements I could make. So... Also, those of you who know security may be thinking, oh, this queued up star file looks very dangerous. It does. It is. That's why this little starlight script, this is considered trusted code. Anything that's passed in by users cannot specify the hypervisor that it's running on unless you provide it from a list of system administrator supplied hypervisors. Because essentially what TinyRange is doing is it's saying, I don't have a hypervisor built into me yet, so go run this other hypervisor instead. This hypervisor happens to be a starlight script. So, argument is an iterable, so we need an iterator. Arguments.iterate. The iterator.done. Args string for argument values, because this is an array of starlight values. I hate variable naming. So for starlight value for iterator.next reference to val starlock.string val. If not okay, then return nil. Return none. Rf expected string got something else instead. Val.type. Arguments.append string. And we just return a starlock. And we just return a vmm factory executable with command set command and arguments set arguments. Which is already a starlight value, which means we're able to do this. And voila. Almost looks like we just ran that little bit of code and ticked off our first item, perhaps. I'm not going to say that yet, though. I'm going to say I want to do a little tiny bit of refactoring first, maybe? Maybe not yet. Okay. So, step 1, get a virtual machine started using Qum and outputting to the screen. Now step 2, get the virtual machine booting an intramfs provided by TinyRange, starting with Alpine Linux. Okay. So, Linux booting 1.0. So, little introduction to Linux booting to make this make a little more sense. What you were seeing here is the output of a virtual machine starting up. All Linux systems have output like this. If I use the my normal version of TinyRange, and I do dmessage, then I can see this is what the output of that TinyRange virtual machine looks like. I'm using TinyRange to do this, and effectively skipping forward a fair bit into the future, simply because I don't want to accidentally leak anything that could be in my host computer's dmessage output. Part of me considered doing this entire development experience inside TinyRange, but part of wanting to develop TinyRange further is make it more possible to do that. Right now there are limitations, especially when it comes to networking connectivity and how quickly the virtual machine can start up and do everything. So Linux initializes all of those devices, and then finally it runs the int process. Right now, we don't have an int process. So, how do we solve that? Well, what is an int process in the first point? So, the Linux kernel's boot up sequence is pretty dumb for the most part. When a Linux kernel startup. One dot. BIOS does BIOS things. I'm going to say both UEFI and BIOS are the same thing here. Just because in both cases, the job is to run some kind of executable, which in turn starts up the actual operating system. In this case, if you're on a normal Linux desktop machine, what happens is you then have a bootloader, which loads the Linux bootloader. You then have a bootloader which loads the Linux kernel. Why does the bootloader exist? Because the Linux kernel itself doesn't understand how to load itself from disk, and the BIOS may not be able to natively call into the Linux kernel itself. In the case of what I was doing in Qum, when I do this bit of code here, I'm not using a bootloader. The BIOS that Qum has understands how to jump directly into Linux. So, in turn, we don't actually care about that. BIOS does BIOS things. Bootloader/BIOS jumps to Linux. Linux is the only operating system that I know of that has a well-defined boot protocol, unlike other operating systems, which is essentially we provide our own bootloader, which interfaces with your BIOS and does everything we need to boot up. Linux, all it does is Linux says, okay, you're going to want to load this elf executable, or maybe you're going to want to load this executable format, which is the kernel image of some description. In this case, it's an executable BZ image. BZ means it's compressed. It's an executable image that the BIOS loads and then jumps to. The Linux kernel does all the rest of the initialization itself. So number 2, bootloader/BIOS jumps to Linux. Number 3, Linux does hardware initialization. Yeah, number 3, Linux does hardware initialization. Depending on the kernel, it could either do very basic hardware initialization, or it could do some quite complicated, elaborate hardware initialization. Depending on the kernel. That's foreshadowing. Step 4. Linux runs the init program. Where does the init program come from? It comes from your root file system. Your root file system is either an initramfs, which is a RAM file system, or it's a file system on your hard disk drive. Or, actually, it can be a lot of other things as well. Linux actually supports booting directly to NFS. For those of you more clued in of computing things, that should be a bit of a red flag. So Linux can boot up into a whole bunch of different file systems. Cool. But does the Linux kernel come with support for all of those built in? No. In fact, if you're running a normal Linux system, like an Arch Linux, if you're running NixOS, I think, or in my case, I'm running Fedora, or any other Linux system, you've probably got a Linux kernel that on its own can't really do anything. All that Linux kernel is able to do is it's able to load an IntRamFS, which is an extremely simple file system. It's just a CPIO archive. It's just a CPIO archive of a file system that it loads. And then it runs the init program inside that IntRamFS. So, that init program there, that init program's job is to initialize the rest of the hardware that's specific to your system. Because recompiling a Linux kernel for every single computer that could possibly run on takes way too long, is a huge pain. TinyRange does it just because there's a lot of functional, just because it makes things simpler. But in most cases, you don't want to compile your own Linux kernel specific to the system that you're running on. If you're running on a virtual machine, could well make sense. Depends on how your hypervisor is configured. There's way too much variation to have one Linux kernel that supports every single piece of hardware. And it actually may be possible to do that, but the size of the Linux kernel and its build times would end up getting so absurd that you don't want that. This local VM Linux is like 10 megabytes, 9 and a bit megabytes, roughly. So, Linux uses modules instead. So the job of this int program is to load modules. In turn, once the modules are finished loading, each module adds a little bit to the kernel. Once all those modules are finished loading, the kernel can continue its normal boot up with files stored on the hard drive. Note, your IntRamFS is still stored on the hard drive, but it's loaded into memory by the bootloader as it's loading the Linux kernel itself. So yeah, and because of that, if we're doing QUME system x86-64, it actually has support for, as well as kernel command lines. It can do intrd to load a specific IntRamFS. We are going to need an IntRamFS to use here, though. So let's do that. So this is step one. Should probably commit this first. I'm actually going to push this up to the repo, but in a alpha branch. And I need to actually push that up there. And that code is now up and public. Need to add a license, which I will just do in the web editor. Spoiler, it's going to be Apache 2. Which means we magically got some changes. Voila. Sorry. When the window does weird things, it's because I'm maximizing or minimizing it on my hosted screen. The stream is 1080p, but my host monitor is 4K. So it's convenient because it means I don't need a ton of monitors on my desk. So I've got step 1 done. Get a virtual machine started using Qum and outputting to the screen. Step 2 is get a virtual machine booting an IntRamFS provided by TinyRange, starting with Alpine Linux. Like I was saying in my explanation earlier, the IntRamFS is very simple. It's just a CPIO archive, which means we need to create a CPIO archive. Yeah. Go does not contain a functionality to do that kind of stuff built into it. So we will have to implement that functionality into Go ourselves. This is where the code copy pasting starts. Because I happen to have in the regular TinyRange codebase a whole nice little pretty bulletproof library that does all this. So this means I will create a package directory and a package I'll create CPIO, and I will touch CPIO.go. File system and file name string and error. So instead of doing all this for a second, let's do create root file system. File name is going to be local intramfs.cpio. And if error is string, error is going to return error. Nice. And then we need to deal with how all of the CPIO stuff works. Conveniently, I've written this code a billion times before. You may ask where we're going to get our source for this. Well, that's where Alpine Linux comes in, because input string, we're going to have an input file which is a string, and Alpine happens to release mini rootfs's, which are the best thing ever. So let's grab one. Okay. So I'll just use TinyRange to show what's inside of this. It is an extremely minimal root file system, but if we chroot into this, then it works. There we go. We have Alpine Linux. So all you have to do is get the virtual machine to boot up something like that, and it should work. We'll need an init script, but that's a later problem. This file is a tar.gz file, so if error equals os.open input, if error is not equal to nil, return error with f.close. reader error equals gzip.reader. The file if error is not equal to nil. Error per reader dot close. And now tar reader is tar.reader from reader. For next if i.bof break, otherwise else if error is not equal to return error slog.info record Another nice thing about Alpine is they provide these mini rootfs's for lots of different architectures. If you want an x86 virtual machine, you can just download one of those. You'll need to bring your own kernel, or you can get a kernel directly from the Alpine archives. That's also doable. So if we now run this again, it's saying that we can't find it. Oh. Because we're just doing that. Okay. We can see we have all the different files inside of here. Most of these files are pretty simple. They're things like directories. So the reason that this is so small is because Alpine Linux uses something called BusyBox. This whole archive is like 2.5 megabytes. Alpine uses BusyBox, and most of these commands that we see are not real commands. They are just symlinks to the actual command. You can see that with the CPIO type flags. The only real file inside of all of these is like the few SO files for the libraries. It also uses Musel, which kind of annoying, but also makes it very lightweight. Makes it a bit annoying to compile software. A lot of Linux software just implicitly assumes it's going to be using glibc instead of Musel, so you have lots of random compile errors start coming up. It's a pain. But yes, so we've read it. So we've read this in. Now we need to write something out. All I'm going to do is I'm going to figure out. I'm going to remember how all this works. Okay. So type package CPIO. So now what we're going to do is say. So one of the annoying things about CPIO archives in this instance is you need to ensure that the directory is created before the file is actually written. Before the file inside that directory is written. Whereas tar, that doesn't technically need to be the case. So in a tar file, there's the way to think about a tar file. So tar stands for like a tape archiving format. It's designed. Whenever you see tar.gz file, it's a tar archive that's been gzipped. The entire thing has been compressed using the gzip command. You can create all the stuff manually using tar command and gz, if anybody can remember the command line flags with tar, which are terrible. But the main implication of how tar works is it's just a series of headers, one after another. After the header is the contents of the file. For most files, there are exceptions. GNU sparse files exist. Ironically, the only place I've seen a GNU sparse file actually used is FreeBSD. But, yeah, so header, contents, header, contents, header, contents, header, contents. You can think of a header as the instructions, the utility of where to write a file somewhere on the file system. And depending on your tar implementation, your header, think of tar as a set of instructions of what files to create on a file system. This is in contrast to other archiving systems which behave more like file systems. They use a proper hierarchical storage of files and directories, whereas tar, it's not that. CPIO is like old tar, mostly. It's very similar, but it's incompatible. No, Linux cannot boot from a tar file. That would make life so much easier. So what we have to do is we have to actually create the CPIO file system. fs is equal to CPIO dot new, and then we just do CPIO fs dot write to our output file name. Error is fs.write, error is like vanilla, return error. So what we're going to do is we are going to get all of the contents of this tar file. We're going to read the entire thing into memory. This is not ideal, but the problem with gzipped archives, which is kind of annoying, honestly, is that you can't seek around in them. Unlike a zip file where you have random access to any of the files inside of a zip file very efficiently, with a tar file you need to decompress the entire thing before you can seek to individual files inside of it. So I'm just going to read the entire contents of each one. How you do that is contents error file.read all from the tar reader. If there was a failure doing that, then these errors are very unlikely to occur, but they sometimes happen. And then all we need to do is fs.add. We'll call this add from tar header contents. If error is equal to fs.add from tar nil, return error. Okay, and now we just need to implement this. New star Also, why do I call this a file system? Because my CPIO implementation is going to be backed by something that looks more like an in-memory file system that just happens to have a write CPIO thing at the end of it. I may end up using this code for other file system related activities in the future, but part of this rewrite of TinyRange is trying to get away from TinyRange doing the build itself and letting other more capable tools like my PKG2 code to do that instead. So in this case, we're just returning a new file system. So we have a func write CPIO, file name string, error, then return I believe that the internal structure of CPIOs is very similar to a tar file, in that I believe that the internal structure of a CPIO archive is very similar to a tar file, in that it's just a list of instructions of what to add to the file system and where. But I structure it like a file system here because I found in my experience, if we try and create a file in a directory that doesn't exist yet, the Linux kernel complains at us. So it's easier if we have this all as some sorted thing, where we are going through and then dumping the tree out to the file, effectively. So, add from tar. Header is tar.header, and contents is byte. This function returns an error. And then I've written a ton of file system code like this, so I am going to be gradually rewriting the code I have in TinyRange, but when I come to actually writing out the final CPIO archive, it's probably going to be pretty differently structured. So we have a type file system here. We have a file system has a root, which is a directory. Directory is a strut. These are all internal. We also have a file, which is also a strut. And then we have a type record, which we have all this will be private. We have a type record, which is an interface, and then we say underscore record equals file, underscore record equals directory. File is pretty simple. It just has a contents, which is a byte array, and a directory is only slightly more complicated. It has a set of entries, which is a map of string to record. Other things like symlinks and hardlinks exist as well, but from the perspective of this file system, because we're not going to be consuming the file system with applications that expect POSIX like complements, we are just going to assume that a symlink is a file, because symlinks are just files. And hardlinks, technically two hardlinks point to the same underlying inode, so we could implement that kind of semantic. We may end up having to, but I think in the case of these kinds of CPIO archives we're doing, we could just think of hardlinks as synonymous with symlinks. We'll deal with this anyway. The first thing we're going to do here is switch header dot type flag. We'll also need a cleaned name which is a header dot name. Default. File system dot app tar type flag. Speaking from experience, this error is going to be pretty common, because it'll happen whenever we encounter a tar file that is more or less unfamiliar to us. So we no one need clean name later, but we're just going to do $_ first. So directory, new directory, star directory, reference directory, where entries is. The Go language server is actually really clever. It says what functions do we know that produce the return value that we need, and surprisingly, new directory will produce it. But if we do that, then we'll just implement loop. So instead, we'll want I normally do make string records, and so we have a func new file as well, and then return file. Arrays do not need to be initialized. Nil array is just a 0 length array. Yay. So we can do that. So when we create the new file system, we need to make root a new directory. Type flag not implemented 53. What is that type flag? Case tar dot. What is 53? Here are all of the different types. They're just names like this. So regular file is 48. 53 I think is directory. Yep. So the first thing that we're encountering is a directory. So case tar type directory parent. So we're actually going to do parent name is fs dot path, and then cleaned name. What does this function do? This function splits up all the different parts of the path and then enumerates through them until we find the particular one that we're looking for. And then once we have that, I'm going to return nil at the end here because I expect that we're going to be doing all of the ch mods and ch owns as one big chunk. Again, I'm writing this code all from existing code that I've already made in the past. So if the error to that's not nil, then return error. You may want to make that a little bit better, but we'll see. So all we're probably going to do here is we're going to have a var int equal var int, which is a I'm just going to call it entry. Var int is an entry. Int equals parent dot make the name. Okay. And then we're going to do stuff with end here. Open path is just going to do fs. It's just going to be a standard recursive function that standard iterative function that opens a given path. So you pass in a path, which we're going to call string, using the shortened form of that name, because if I was to do the full thing with path, it would conflict with a path library with a path package inside of Go. So p string. This will return a star directory. It'll return the base name, which is string, and it'll return the base name, which is a string, and it'll return an error. And firstly, we've got to split it. So tokens is p.split /. Tar files, I assume, always use Unix semantics for directories. So that means Windows uses slashes, uses /, I believe, and Unix uses the other direction. In Go, you can use file path to automatically use whatever the host operating system uses, which you should always do whenever you're opening files. Ask me how I know. But in this case, yeah. In this case, we're just going to split it on / manually because we always know that's how it's going to be. So I'm actually going to do a little bit of printf debugging and see what the value of tokens is. Because I expect that first one is just going to be trying to create the root directory. Then return nil. Not implemented. Parent.makedir doesn't exist. Directory doesn't have a makedir function. Probably needs one. Directory name string returns another directory. Child equals directory. Entries name equals child. Return child. Okay, we have two tokens. One is empty string and one is dot. That's because every single one of these starts off with a dot / at the start. So we're just going to trim all that. That's why we did the clean thing before. So trim prefix header.name dot /. You can also see that all directories have a backslash at the end of them. So, in fact, that approach to cleaning is probably not the best. We should just have a better way of dealing with it, which means we're going to be using path.clean. Path.clean header.name. So, okay, in this case, it just has a dot. So I think this is saying just the current directory. So if tokens 0 is not equal to dot, current is fs.root is not equal to dot, turn nil. Range fs dot this is probably the place where I'm going to be a good person and write a bunch of unit tests for this. Eventually. Not right now. Okay, so return current tokens tokens equals, take a slice out of that, skip the last token at the end, and then len tokens -1, then nil. Return slice bound out of range. Okay. If len tokens is more than 1, then do that. Otherwise, return current tokens 0. No. Okay. Then so this first one, we know this first one's going to be the root directory. How do we know we're expecting to return the root directory? So if len tokens equals 0, else if len tokens is equal to 1, return current empty string and nil. Panic. That's unreachable. Misformatted path, sys. Okay. Oh. The result of cleaning it means that we don't have the first token to deal with. That makes things easier. So, children not implemented media. Right. So child okay is current.entries to k. If not okay, return child not found. Let's just keep a running thing up for I decay. Child at s not found in at s, and then tokens join slash character tokens only up to I. Type flag not implemented 50. Okay. Sometimes, just to make things easier, I will implement this kind of function so that it automatically creates all the parent directories for it. But this works. So that's considered unreachable. So 50, I think, is regular. So parent name is equal to thing, int equals parent dot create name. F, which stands for file dot contents equals contents, then int is file. So create star directory create name string. This returns a file instead, but otherwise it's exactly the same. Type flag not implemented 50 still. Oh. No. Okay, star.symlink. Symlinks 50? Symlinks 50. Okay, so this isn't a regular file, this is a symlink. Where to? Now I'm curious. Have I made a mistake? Target name is name, target is header.name. Ah. Also, do that. Ah. Okay, oh, header.LinkedIn. Ah, yes. Okay, here's one of the cute things about symlinks. Symlinks are pretty dumb. Symlinks are just files. So we've actually encountered this one here. What's the implication when I say a symlink is just a file? Well, see that link name there? If we're extracting that out to the file system, where is it? We haven't written that file yet. In fact, we won't write that file into a fair bit later. Symlinks are just a file that has a path in it, and reads to that file will be redirected to that path instead. All of that resolution happens after the file has been, as the file is being read, or as things are happening to the file in the end. So, yeah, that's how symlinks work. So we can do this standard parent name is open file clean path, and then we can make a symlink. How are we going to make a symlink? That's a good question. We are probably just going to create it and have a function on a file that turns it into a symlink. Make symlink to tar. So we'll just have a function on this that turns it into a symlink. Then function file make symlink. Can't return an error because all this does is that link name equals file.link name equals link name. Kind is, so the kind of a file will probably have to be the CPIO file kind, and I'll just have a look at that. Yoink. So kind is CPIO kind. So a file by default is a regular, but now file.kind is a symbolic link. Contents is not currently used, that's to be expected. Okay. And then entry needs a kind method which returns a CPIO kind. I will also just make the implementation details of these private, because they don't need to be public. This actually gives us our first method that we need to implement here. So kind of a file is return file.kind. Whereas the kind of a directory is always a directory. Flag not implemented, 48. 48, I think it's actually regular files. Okay, not implemented. As it turns out, for this, we only needed 3 different types of files. I think that this is the right CPIO function that's not implemented. It's the right CPIO function that's not implemented. So write CPIO is not implemented. How does write CPIO work in my other code? And we also need to make sure to do info header.file info. So this is why we did ent at the bottom, ent.chmod header.mode, ent.chown header.id header.gid. Yep. So we actually need to chmod and chown these. Chmod will just take a mode fs.file mode, and chown will take a uid int and a gid int. Type. And I will actually just make this an implementation, uid int gid int mode fs.file mode. The reason we do this is it means that we can just say this. So Go doesn't really have inheritance, but what it Go doesn't really have inheritance, but what it does have is it doesn't have object-oriented inheritance. It has interfaces, like you've seen, but as far as like its inheritance goes, you can combine multiple parent objects into a child object. So like the fact that I just had this one CPIO entry isn't really a thing. Also, I could have interfaces can inherit from other interfaces as well. So let's just say this. These really simple methods. ent.mode equals mode. Alright, to keep functions this short on the same line, ent.uid equals uid, ent.gid equals gid. Because this is two statements, I'm just going to give them separate lines. Right. And info.mode. Okay, so now we've got all of that set up. So now we need to implement the write CPIO function. So write CPIO just looks like okay, so we need a write CPIO function which just takes a name prefix. So call this right, and wo.writer prefix is a string, and this function can return an error. And I will implement this individually for file and directory, because I expect file and directories implementations to differ a bit. That additional line here says that it shadows. That just means that when you do inheritance, you can actually still do overriding of methods. It's quite nice. So CPIO entry itself does not implement that, so I will make it implement that, but I will just say its implementation panics with an unimplemented error. So if you try and call CPIO that directly, this is essentially just a virtual function. It needs to have some kind of implementation. So we need to create out error is equal to os.create a file name error is nil error close, and then return null. Error equals fs.root.write out, and prefix is empty string, error is nil, return error. So I can also see that in my old code implementation, I also had to write a trailer and some trailing bytes at the end of it. I vaguely remember that the Linux kernel complained at me if I didn't do that. But let's not and see what happens. It'll be fun. The trailer just looks like a regular file. Okay. So how does write CPO work? Oh, look. The original CPO code that I use for this, I believe, comes from uroot, which is why you're about to see a bunch of code that I didn't really write getting added to this. Where's the CPO mode declared? Okay, it's lowercase. And export all these functions. I think part of this is additional debugging functionality. CPO header, string. Look at that. CPO new C magic is just this up the top here. Oh, try unexported. Cool. There we go. Nice little bunch of functions. I'm actually rethinking my decision to make these implementations like that, and I'm going to bring the implementation back up to entry instead. And I'll have things implement like a slightly different way of doing things instead. So how does the it's got an allocate inode function. That makes sense. Not really, but okay. So there needs to be unique inodes on all of these. And this code was putting a right header, right content. Okay, that's a fair implementation. Okay, and now this means for entry which is declared just here, right, will actually take a CPO writer. Which means these functions are no longer implemented correctly. CPO writer. Okay. Which means we need to just create CPO writer for apt instead. There we go. And then guess what? This right implementation looks like this. Make CPI mode. Int.kind. .mode. .uid. .gid. .content. Let's just make content equals int. Okay. I also need to unexport all of these. Can you unexport them just by doing underscore CPO dot? Yes, you can unexport them just by putting an underscore in front of the name. There we go. CPO is now a very clean, very simple API. All this stuff, that's an internal thing. And in fact, we don't really need those or any of those as well, but let's just keep them. It may make debugging easier. Alright, allocate inode, make the header, int.content, int doesn't have children. That is not needed, I don't think. Oh. I forget if the methods called on this affect thinking what to do for this. Oh yeah, child doesn't yet exist, but it'll be deleted when it does. Okay, so there's end.children, which is also needed for the number of links, which is part of the CPO header. I don't want to make each individual thing get its own header. Okay. I'll handle root stuff later because I can tell that that's not going to be correct because root doesn't currently have a name. There it does. It does now. So how do I get int.children without making this kind of ugly? Also, the m time is set to time.now.unix, which is technically incorrect. I should allow the entry to set it so modified time. It. Time. And also add a ch times time. There we go. I just improved it over the previous version of the code by making this code effectively deterministic. Unless the ordering of the items in the hash map is non-deterministic. Which it is. So I can add a function to get the children. Children, which equals an array of entries. Children. So okay, I see interesting improvements I can also make to that in the future. So the fact that this one is unimplemented, and by removing the implementation on the file, so we shall see what happens. Oh, yep, it's just you next time. Cool. There we go. This should now work. Which is a lie, it won't. Okay. The value of inode is never used. Okay. Yep, this does not work like how I wanted it to. That's annoying. So okay. So right now has to take the entry that's being written, which means we can just pass it child explicitly. This is first boot. Okay, similar error. But if we check now, we can see it's this one instead. So we can, a file naturally does not have any children. Then we just get not implemented again. This should be this one here. Okay, so if we look in local and we do file intramfs.cpio, it's an ASCII CPIO archive. Cool. now we can get the kernel to load it. So we'll always create the root file system first, and then once we've created the root file system, we will run the virtual machine. So now we just need to, so if we do this, if we do this, then it still says not implemented, but we've actually implemented this method. So now we can return nil. It starts up, it does nothing different because we still need to have it actually use that CPIO. So we'll just clean it up a little. I think it's int_rd, local ls local ramfs.cpio. Right. The fact that this failed, so the kernel should have tried to open the intramfs. Okay, it unpacked it, but then it didn't say anything was going on. So int equals /int. The fact that int_rd memory is the entire size of the intramfs makes me think that we forgot the trailer on the end of it. So that trailer is pretty easy to add. Trailer. So that trailer is pretty easy to add. It's just two different parts. So when we do this, we also do file CPIO entry kind regular name trailer name dot write. So this is the trailer dot write trailer Okay. My old code, I just wrote a bunch of random bytes to the end. Not random bytes, just 4096 bytes. Still doesn't work. I'm going to take a wild guess to say that the prefix things that I was thinking is the problem. So what I'm going to do is I'm going to start up TinyRange virtual machine to check to see that that CPIO that I made is correct. I'll call And cpl-h, just to remember how this works. Doesn't support -f command. Nope. Oh, -f, -t, -f, capital F. Nothing is inside of it. Spooky. What's that? 7-zip? 7-zip L. Ooh. That means I got this very wrong. So let's see what it looks like. Okay, that looks fine. So I think the file names are probably the mistake. Org.info, prefix. Of course, I'll see none of this output if the virtual machine actually starts up. So let's uncomment the start the virtual machine up part of this. Oh. Prefix is always /. Wrong. Definitely wrong. Child dot write prefix name dot name. All of the names are empty string. E dot. Okay. Let's give this a name string. All empty string. Very handy. So let's just make file and directory contain pointers to these rather than the thing directly. Oh my luck, that's probably the issue. So what I was saying like 2 hours ago about not about being sure to be very careful about, okay, why is that still empty string? Ah. Boy. Okay, prefix is always equal to empty string. That's fun. Okay, let's have a look at this original code again. I'm going to take a wild guess that... Yep. Alright. Okay, that now looks correct. We are probably getting some... Yes, I know none of those are used right now. We're probably getting some weird thing going on. Let's actually run the virtual machine and see what happens. Okay. Still unable to mount rootfs. Okay. Let's debug this. -t. No contents. I'm going to take a wild guess to say that until we can get that part working, the rest of it probably is not going to work very well. So less local... Okay. I don't think that's the mistake, but might as well check it out anyway. So the mistake I thought was that the mistake I thought is that if you look at this, you'll see that we have opt/opt, which is incorrect. The name prefix is always having the entry name. So we're creating a directory, then an identically named child inside it, which suggests another bug with the open path code. So that's probably has to be -2 instead. Child nil is not found in user share. Okay. Oh, child APK is not found in user share. Why not? .info last is okay. That looks fine. That looks fine. Child APK is not found in user share. Okay, why not? He is usage. Okay, so that is the base name correctly. Plenty of bugs in this code. Which tends to be what happens when you write code like this. CPO entry has got entry map bin. It's just got a dot inside of it as well. Yeah. If. Yeah. Okay. There we go, that dot's removed. Now I've got a weird empty string, I think, as the name. Empty. Okay. That fixes things, I guess. This is still mysterious. Okay. Okay. So that's the writing code at the end. Let's not comment that out right now. Okay. Top level directory. I expected that. Oh. Oh, okay. That looks valid. Closer to valid, at least. Oh, CPO does not store it in link name, it stores it in the file contents. So link name doesn't exist, surprisingly. File.content equals byte link name. Okay, that looks correct. Except for the fact that we have duplicated directories. Whenever directory needs a name. Okay. Rename cleaning. I'm just gonna start to do some of that debugging for that, for the right code, just because I have a feeling it's starting to work. Okay, clean name equals dev temp parent thing. Oh yeah, shouldn't do that. Current path is thing, cleaning equals keys. Let's get this correct. What about when the actual directory itself gets created? Cleaning equals user bin, parent equals local name bin, yes. So that dot's correct. That being a directory, well, it's not actually a directory, it's not correct. Feels like there's just some very small logic bug remaining with this. I'm curious too if that's how it looks in I'll open this up in the hex editor. We're not going to be able to see this unfortunately, but let's have a look. Actually, no, I may just be able to be as good. We'll hate this, but that works. This one is thing, second one is lib apk lib apk exec lib apk db lib apk triggers. Okay, that makes sense. Not really, but name equals name prefix colon plus the entry dot name itself. Okay, simple enough. So what's this value? Install info like that. Oh, name is actually. Oh, child.name is probably supposed to be int.name. Okay. Let's see if that looks good. Yep. Yep. Oh, cool. And let's actually start up the virtual machine. Right. Unable to mount rootfs still. It's getting an MFS. Let's just try extracting this out. CPO-T first. Okay, that looks correct. CPIO dash H. So CPO dash I MFS CPIO. Can't open empty string. No such file or directory. That's the thing that happens right at the very end. Okay, we have a busy box. Obviously there are multiple errors with this. So let's go down them one at a time. Firstly, the only other difference I noticed with the old code is that it does, if it's the root, then it will always, okay. Let's just not run the actual virtual machine right now. Main. If main is equal to dot, which indicates the root directory, dot name is equal to dot, then prefix equals empty string. Okay. Right. That looks good. Why didn't those symlinks get created? They're pointing to an absolute path, which can actually be a security risk. So I suspect it's intentionally done to avoid security issues. Because if you can have a symlink pointing to an arbitrary point on the file system, because symlinks have different permissions in the file that they point to, you can use that for escalations pretty easily. Okay. Unable to mount rootfs. Dumb question, I know, but this is a custom kernel. So does it even support booting from an intRd? I probably didn't add support for that unless it was necessary. So let me just grab a different kernel quickly. I'll grab the vert kernel. CP tab projects. Let's grab the virtual kernel and put it in and put this in local. Alright. Alright, now we have a VM. And we have a VMZ. And if we replace the kernel that we're booting with that one, we can see if it works. Let's just try creating init file first. So all we have to do is do. The thing is, we can create synthetic files very easily. I can add a more convenient wrapper for this in the future, but no matter. tar.header. Minimum use type flag, regular name is /init, and the oh. Yeah, name complex. No perm. I think that should work. Yeah, let's go with that. Mode, size, script equals. Just that is an init script. It's also possible that I'm missing a command line parameter for Qum, because when I do this and inside the other TinyRange code, I also add a few others. Defaults and the user config. And I'm not sure if that makes a difference, but no graphic is normally added after that. And then, because I did that, I need to do serial stdio. Okay. So it unpacked the int_ramfs. So let's see how well our int_ramfs looks. Okay, cpo-h. So can't open empty string, no such file name or directory. Okay. Do this on my host quickly. Malformed header, file name of 0 length. Premature end of file. Okay. File name of 0 length. I can do the validation here to see what's going on. If ent dot if then name set up this yet again. Oh. Oh, it thinks that its lengths are correct. Malformed header, file name of 0 length. Is it because the first one's technically 0 length? I do have other CPR archives that I have TinyRange generate which do work fine, so let's see what they look like. So if I look inside the kernel, The fact that it only goes to var empty makes me suspicious. What's after var empty? Okay, so in this case it goes down to etc group. The directories, is it something like directories always need to have a backslash on the end of them? No, doesn't look like it. If it's a directory, then set nlinks. Nlinks defaults to 1. Children should probably go up 1 to just here. Writes the header. I don't need addiv major and addiv minor. Unless for some reason they're set to some kind of default, which is unlikely. Nope, they are not. End root. How is root set? Root is just set directly on the thing, which makes sense. When it comes to the children, when it comes to the child entities, let's make sure that this is sorted. Sort dot slice. Slices dot sort func. This is the new version. simply calls slices.sort. Fun thing about Go is you can actually just look at the source code for all of these. PDP sort. Okay, so turn cmp dot compare a dot name b dot name. That'll make sure that this is all strictly ordered. So bin comes first, then dev, then et, then it gets to home, then it has a bit of a problem. Let's see, is that stable? Yes, it is. Okay. So that means I'm going to reload this in a hex editor and look for hex. Okay, so file name of 0 length. Okay, what is it store the length of the file name? Length of the header dot name plus 1, and then 0x00. Home for some reason already has a 0x00 after the end of it. But that is, I assume, padding bytes. So the length of the name is stored in hexadecimal for some reason. As 5. So that's correct. So the metric's correct, and it's reading through most of it correctly, but it just runs into the thing after home, pre-meteor enter file init. So init's right after home. Does that happen if the init file exists? It may be some weird thing where the init file is causing this. Okay. So, for lots of things, there's also var temp, which it's got trailer right after the end of var temp. So, in one instance, it's not correctly reading the trailer, which is possibly what's causing the Linux kernel to complain about it. And in another instance, it's something about my init thing being weird. So it's mode perm, it's type flag is reg, its UID and GID shouldn't matter, its byte contents is the init script. Okay, so let's just try an empty thing where we comment out all of this code and uncomment the CPRFS. Okay, in which case we just have the root directory in it and then a trailer at the end. Now from tether, file name of 0 length. Immediately. Okay. Is it possible that my directory is not being written out correctly with the right kind? That's a possibility. Now it's stable at least, which is good. So I know it's being caused by the ./init. So let's look at add from tar again. It's going to be a typereg. Its mode time is 0, but that doesn't matter. Its mode is going to be mode perm, which is just equivalent to 777. And its ownership is going to be user 0, group 0. Right? So let's see directories. Directories have a kind of type CPO directory. But the thing is, if we use less, we can see that all of that is actually being handled correctly. You can see that it just gets to home and then buffs, which the other thing is as well, which means it's probably having that same problem and then silently failing on that error at the end. How this less command is doing all this, not sure, but it's useful at least. The fact that it's happening for my init script particularly is a little bit weird. So what if I was to call this A instead? Then in which case it's something about my file that's weird. Okay. The size is the length of the init script. Type flag. Name. Okay. Info. Header. This is just a list of all the files that are in the thing. Header, name. So it's // So it's // doesn't have a mod time. That shouldn't matter. And it, unless it does matter for some reason. Time. Oh, okay. So the fact that it was always setting that mod time on it was a bit weird, I guess. Well, fixed I guess quite likely fixed. So let's just see the trailer. Name the trailer name, mod time is time.now. Okay, and then CPO. All right, that is now a valid CPO archive. Nice. That is not what I expected in the slightest, but okay, I guess. Do you work? You do work. Awesome. We now have a Linux system. That was. Okay, once that started working very quickly. And we can exit the Linux system and it stops. You can see that it has all those errors. That is to be expected. get the virtual machine booting on an RMFS provided by TinyRange. Let's just see if it was a problem with the kernel I was using. Because I'm kind of curious. I don't think I... And you can see that that kernel is actually bigger than my kernel. Even though it needs modules for things. Okay, yep. My kernel works fine. Nice. You can also see one of the reasons we're working on this kind of stuff in the first place. Look how fast that is. If we were... And now we have a simplistic version of TinyRange. Because I can just do something like exit straight after that. And it terminates straight after that, so we can remove the logging in the CPO code. Because I, of course, would not like a whole ton of debugged spam whenever that happens. And... Who would have known that that setting mod time to 0 would cause the CPO archive to be invalid for some reason? I would have never guessed that. To fix these bugs, you either have to search online, which, thinking how often other people would have run into these kinds of issues, it's not often, unfortunately. Or you have to, like, actually dig into the tools and things themselves to figure out what's going on. But yeah, if I time that command running, there we go. We can now, in less than a second, boot up a virtual machine, have it do something non-substantial, and shut down again. And it boots up from our own file system that we specified. And we did that in how many lines of code? 250 plus 450 is 700 plus 20. So 720 lines. So 720 lines of code and about 3 hours. We now have step 2 of that done. Step 3 coming later, I guess. But I'll commit this for now. Let's just check if we made any big messes of things that I don't want to commit. Let's make the virtual machine a little more useful. Whole bunch of very simple modifications to things, and also the CPO archive, which compared to the old version is now simplified a bit. Why is the M time having such an influence on things? That's something I find curious. Because technically speaking, this whole code will be deterministic if not for that M time thing. And if I comment that out, it fails to boot. Just confirming, if I comment that out, it fails to boot. No, it doesn't. Okay. If I comment that out, it fails to boot. Yes. Time. Okay. It's possible that it may have been outputting some weird negative time that was causing issues. That's going to be my theory. But now on the plus side, that means that code should be deterministic. So m time will also just be set to a 0 time. If we look at this, then we'll see that int was last changed on January 1st, 1970, which is incorrect. Which is also why you shouldn't trust the statistics on any of this stuff, because the archive can make arbitrary changes to all of this, which is kind of cool. So, okay, when I say deterministic, what I mean is SHA-256 local int fs.cpo. It's that. Then if we were to run it again, it's exactly the same. Every time you run it, it'll be exactly the same, and it also maintains the information and metadata, which is a change from how the original code that I based this on did it, which is nice. Comment-n step 2 get and yes, this code is public. Right, that is like pretty much 3 hours on the dot. That's fun. Number 3 comes next, but that is going to be a tomorrow problem. Number three is going to be really pretty easy, because it's just a matter of writing out the file from the host. Number 4, connect networking from the host to the guest using gvisor netstack. That's a whole pain in the ass. That's a lot of code to write. Number 5, write a DHCP and DNS server in the host for the virtual guest. That's easy. There are libraries to do that I've used before. Number 6, switch from using stood out from QEMU to SSH from the host. That has an implicit side thing to it, meaning we have an SSH. So that has a few parts associated with it. That's a bit more complicated. Connect an ext4 file system exposed as NBD network block device from the host. That took me like a month to do when I initially got that working, a month or two to do roughly. But then after I got that implemented, I have the code, it's stable. I'll just copy paste that exact thing, since it's also relatively modern code that's not terrible. With a full Linux distribution from an OCI image. As soon as number 7 is done, number 8 is quick to follow. Number 9, write a network caching layer for the virtual guest so it can download packages. Nothing too complicated about that. Number 10, add support for connecting to arbitrary websites in the guest. Again, nothing too complicated about that. Then after that, we can add additional things like number 11, let's add that already. Number 11, make the virtual machine customizable. Customizable notably because, fun thing, the current virtual machine we're running has the default amount of memory. And rock, rock. This virtual machine has the default amount of memory, which is like 128 megabytes, and it's still running. It's still running fine. This virtual machine is taking up no system resources essentially, which is pretty cool. But yeah, number 11, make the virtual machine customizable. It's just like 2 parameters, and we can set an arbitrary number of CPU cores in RAM. But yeah, making the virtual, including customizable scripts for when the virtual machine boots up. So right now this virtual machine is not connected anywhere, and it can't really do all that much. You could run benchmarks and things inside of it, so long as you can get car archives, you could probably get that working, but you'd have to modify the Go code right now, which is why I say make the virtual machine customizable. And yeah, pretty much 3 hours on the dot. Perfect timing.